Hi, I'm Dr. Ben Newman. I'm a coronavirus researcher, and I do my best to answer your questions based on experience with molecular biology. When we have other questions, I do my best. Let's see. The next question is from Renee, and how you doing? Good to hear from you. Yeah. Let's see. Renee's question is topical. Yeah. I keep hearing how cloth masks are no longer as effective as surgical or N95s. Yeah, that is what people are saying now. It's not that they're any less effective than they ever were. It's that they were always a bit less effective, but we were making do. That's I think the short TLDW approach. So thanks. This has been Ask Dr. Ben. If you want the details, stick around. All right. Is it that the masks are not the ones that are like 2 or 3 layers of cotton? And I thought the early research showed that proper cotton masks were almost as effective as the others. Yeah. The science didn't change. It's just that with the alternatives have changed, and there are reasons. So, all right, let's go for reasons. So I read a bunch of papers for this, and there are a lot of different ways to measure mask efficiency of increasing sophistication. So there are some where they're just generating the particles, and that's nice. You can make particles of roughly a particular size. But when you breathe or when you talk, you're making particles of lots of different sizes anyway. So, yeah, I think this is more just like so that they can say, okay, big particle, small particle, how effective is it? Because sometimes there are differences. Yeah. And there are some setups that I saw where they'll have actual like mannequin heads that are wearing the masks. That's really nice. I've seen some where they simulate coughing. They'll have like a little device that forces a cough's worth of little droplets out. And you can put little markers in the droplets, or you can just use optical techniques and you can record the droplets, like how many there are and what size they are. And so you can look at what gets through, or if you put something in the droplet, you could see how much of that stuff ends up inside the mask. Yeah, like that. Okay, let's get into it. So this is a representative paper. It's not the only paper. There are tons of them. And there are slight differences because everybody does the test a little bit differently, but they tend to show the same thing. The same rank order appeared over and over and over again. So I feel like that ought to be a good indication that we can be confident. But here again, you would want to talk to a material physics person. They would be more expert in actually interpreting how the test was done and being able to critique, well, this is a better one, this is not as good. Yeah. So with that aside, here we go for our non-expert version of this. There we go. So the two things that everybody likes to measure are effectiveness and breathability, essentially. So you want to know how good is the mask at stopping stuff from getting out or in, and I don't know of any masks that are directional, that like only work, filter going in and don't filter going out. Because, think of that. If you had something that wouldn't let air in but did let air out, you'd suffocate. And if you had something that let air in but wouldn't let air out, it would inflate like a balloon on your face. And that doesn't happen. That does not really happen. Okay, so in terms of the size of the particles, so these little droplets that they're measuring are about the size of, 16 nanometers is smaller than even the core. If you took a coronavirus and shaved off all its spikes, it would actually be a little bigger than that. So that's more like rhinoviruses are actually a little smaller than that, but I think they had an apparatus that could make droplets of a size, and darn it, they used it, and so good for them. Yeah. And then over here, the 125, that's closer to coronavirus with all its spikes on size. But there are other studies that show that coronaviruses do not tend to come out of people as just like dry little dusty viruses that float through the air. They tend to be in much larger blobs of water. So coronaviruses tend to, travel in their own little miniature lake, which is still tiny. But Yeah, there are other viruses that are more likely to appear as aerosols, like more or less just virus floating in the air. But yeah, apparently not corona. Who knew? Let's see. So here we go. This is the effectiveness against little drops and big drops, and you can see all these little things here. So the 2-layer cotton mask, still decent. And this study shows about 40% efficiency at blocking the little droplets, and I don't know, somewhere between, looks like about 10 and 30% efficiency blocking the big ones. You would really want to know how good they are at blocking even larger droplets, and those tend to be easier to block by all these masks. So these numbers that you are seeing are low for what real-world coronavirus protection would be. So you are more protected by your mask than these numbers would indicate, most likely. All right. You can see up here on this end, you got KN95 and you got your 1-layer and 2-layer cotton mask. So just based on that, you say, if you have a choice, I'd wear a KN95 or something like that. Even a medical mask, though, look at that. It's pretty good. You're not sacrificing much. And they're all over the place. And they're fairly comfortable to wear. Yeah. So those are the ones I generally wear day to day. I do have, I think, 2 KN95s that I get out whenever I reach for the nearest mask, you know? All right, so that's the first part. And here's the second part, pressure drop. So like how much, basically, what's the resistance of the mask? And so they have things like a coffee filter here, which is not great to breathe through. You don't want to use the coffee filter as your mask because, yeah, like a cotton mask is going to be more comfortable. There are other kinds of things that are more and less breathable, if you like. Giving you air with relatively little, relatively little extra work. There's always a little tiny bit of extra work because you have a mask in place. So you got to pull in a little harder, and I know that makes people feel a little uncomfortable sometimes. It does me if I've been wearing it for a while. And a lot of the time, I think changing the mask out can help, because if you've been outside or it's really humid, you'll sort of clog up the mask, I think, with a lot of water vapor. And pop a new mask on. Oh, it's so much nicer. Just dry the old one out and use it again. There you go. So yeah, those are the numbers. And so those suggest that cloth masks are okay, but not the best, but okay. And if that's all that's available, a whole lot better than nothing. Whole lot better. But then you get things like this. So this is taking a different approach, and there, if you want to have a look, and this is like a super team. I don't know that there are any 2 people from the same place. There are a lot of influential places there. So it's a bunch of people that got together to put their review of masks. Here we go. So this, I think, is interesting, and so this is more like why you're seeing the change in the recommendation. So this is saying if you've got masks, so first of all, the numbers here. This is the R effective. So this is the rate at which the virus is going to spread. So if it's a 2, that means that if you're infected, you're going to infect an average of 2 other people. Yeah. And if one person infects 2 people, then the amount of virus goes up, 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 like it is right now. If the rate is 1, that means for every 1 person that's infected, that will infect 1 other person. That's sustainable virus transmission, which is something we also don't want. And if the number is less than 1, so our blue colors up here, that means that 1 person who's infected is going to infect, on average, fewer than 1 person. And you take a bunch of 1 people who are infected, and they will infect fewer than the number of people that you're talking about. And that's good, because that means at that point the virus actually goes down and eventually goes away. So you want your R value, R effective, to be less than 1. That's the idea. Basic reproduction number, I think, is what it is. But that's an epidemiology term, and I am not an epidemiologist. I don't even play one on TV. All right. So what this is saying is that they're looking at, okay, how well does a mask work and block the virus? And so they got it from 100% effective down to no percent infective. Yeah. And over here we've got adherence, which is a combination of, in this case, they're modeling the proportion of the public that wear masks. I would say, though, put into this the number of people that wear their masks in a way that actually blocks air. Like I was walking around a school the other day, and of adults there, I think some of the kids had masks on, which was nice. But of adults, I think I saw one mask, and then I saw two others that were down like under their chins. And if you're wearing it like that, it's not doing you much good, and it doesn't. It just looks weird too. I have no idea. Just pull it up. Yeah. Anyway, see this curve? So if you have really efficient masks, but only a few people wear them, you still end up at an R number of 2 or more. And if you have super inefficient masks, but they only block like 10%, so everybody's wearing those little gaiters like you get from the hunting catalog. You can still end up at a R number of 2 if every single person is wearing that. So even though they're pretty ineffective, you can have an overall aggregate effect. So what they're trying to do is they're trying to move us in this direction to get us toward the blue. Because I think in this direction we're kind of fixed. You can do all the PSAs. Every day my YouTube gives me a whole little line of COVID PSAs, basically. Yeah. And I bet the people that are already doing them watch them, and I bet the people that are not going to do them just skip right past that little line. So I think the adherence part is probably fairly fixed. There would be a portion of people who would wear a mask when things look bad or it seems bad based on, whatever they've heard. There would be some people that would always wear them, and some people that, no, they're going to die with their mask off. Yeah, that kind of type. So I don't know that you can really move this number. I think that is dictated by the situation and the people. And so they're trying to pull the one lever that'll actually move a little bit when they pull it. So they're trying to take these sort of 40% effective cloth masks and bump them up to maybe a 90% or 95% effective mask, like a KN95 or a surgical mask. And yeah, you can see it would be predicted to have a pretty good effect. So there you go. That's what they're getting at. And also I would say with the KN95 specifically, it's really hard to wear those badly. It's really hard to wear those in a way that they don't work, because they're kind of really long, and there's just, it's hard to do. Whereas with cloth masks, I see ones that are way too small, where it's like a little postage stamp and it's got gaps all over the place. I see ones where it's like a tent on the end of the nose and the air is really just going in and out under your eyeballs, and not going through the mask at all. See all kinds of things, like where the elastic has got worn out and it's not pulling it tight anymore, or because you keep pulling it down to talk and then pulling it back up again. Yeah. So I think you probably get better compliance just sort of accidentally if somebody's wearing a mask, if they're wearing that one. So maybe it does bump this number up a tiny bit, and definitely bumps this number up. There you go. So it was math all along. Who knew? Yeah. Sneaky mathematicians getting in your business all the time. There you go. Thanks very much. This has been Ask Dr. Ben.